For over 100 years, engineers have designed some of our most critical metal parts. Think airplanes, bridges, all that stuff. Based on this one really powerful idea, that if you just keep the stress low enough, a part can be flexed or vibrated literally forever without breaking. But what if that whole idea is just wrong? Okay, let's really get into this because some pretty groundbreaking research challenges that entire concept. We're going to explore the science that's forcing a complete rethink of what forever even means for the materials we all rely on every single day. So, where did this idea of an unbreakable metal even come from? Well, it all boils down to this one core engineering principle that's been taught in textbooks for generations. It's this concept called the fatigue limit. The theory is actually pretty simple. Keep the stress on a metal part below this magic number, and it will supposedly never ever fail from fatigue. Doesn't matter how many millions or billions of times you load it. It was like an engineering guarantee for infinite life. And this right here, this is the classic proof, the SN curve for steel. You've got stress on the vertical axis and the number of cycles along the bottom. Now at high stress, over on the left, things fail pretty fast. As you lower the stress, the part lasts for more and more cycles. But look what happens way out to the right, around 10 million cycles. The curve just flattens out. It goes horizontal. For decades, that plateau was seen as absolute proof of a fatigue limit. But here's our first clue that maybe something's not quite right. As far back as 1999, Bathias, the very researcher whose work we're digging into, called it a convenient and economical approximation. So right there, he's basically saying, hey, this is a handy rule of thumb, but it's not the whole truth. So, if it was just an approximation, why did everybody believe in it for so long? Well, turns out, for the longest time, we just couldn't see past that 10 million cycle wall. I mean, think about it. With the old machines, testing just one single metal sample to 10 million cycles could take over a month. So trying to push past that to 1 billion cycles, you'd be waiting for years. It just wasn't practical. It was not gonna happen. And this is where the whole game changes. New ultrasonic testing machines came along that can vibrate samples at 20,000 times a second. Just look at the difference that makes. A test that would have taken more than 3 years can now be done in under a week. All of a sudden, the door to the giga-cycle regime, 1 billion cycles and beyond, was blown wide open. And the moment researchers could finally push past that old limit, that convenient myth of the forever metal, well, it started to crumble, and fast. They started with the classic high-strength steel. This is the exact material whose SN curve was supposed to go flat, but when they tested it out to 1 billion cycles, it didn't. The curve just kept on dropping. There was no horizontal line. There was no infinite fatigue limit. And we're not talking about a tiny dip here. The actual fatigue strength at 1 billion cycles was 60 megapascals lower than the old accepted limit. Now, for an engineer designing a critical part, that is a significant and, honestly, a pretty worrying reduction. Okay, so what about other advanced materials, like, say, the titanium alloys we use in aerospace? It was the exact same story. Researchers found that failures just kept happening, way past 10 million cycles, and the material's strength just kept on dropping. And for titanium, the drop was even bigger. The strength fell by a massive 100 to 200 megapascals. For an industry like aerospace that depends on the absolute predictable durability of this material, this was a huge discovery. So finally, they looked at nickel superalloys. These are the really extreme materials used inside jet engine turbines. And guess what? The result was exactly the same. Even these incredibly high-performance alloys showed a major drop in strength deep into the giga-cycle regime. There were no exceptions to the rule. For the nickel alloys, it was a 200 megapascal drop. So the point is this. It didn't matter if it was steel, titanium, or a superalloy. That forever fatigue limit was a myth. It was an illusion created purely by the limits of our old technology. This all raises a really fascinating question. What on earth is happening differently at 1 billion cycles that doesn't happen at 1 million? Well, the answer is wild. It's a complete change in how the material itself actually breaks. This part is so cool. As you can see, everything flips. In traditional fatigue, under about 10 million cycles, cracks almost always start at the surface. That's why having a perfect, smooth surface finish is so important. But in giga-cycle fatigue, way out past 100 million cycles, the failure starts deep inside the material. The battlefield completely shifts from the surface to the core of the part. So what's kicking off these internal cracks? It turns out to be these microscopic imperfections that are just baked into the metal when it's made. We're talking about tiny impurities called inclusions, microscopic little voids or pores, or just weird spots in the crystal structure. These are like tiny little time bombs, just waiting to start a crack that grows from the inside out. And really, why does this happen? It all comes down to a simple numbers game. Any piece of metal has way, way more volume on the inside than it has area on the surface. So when you flex it billions of times, it's just statistically more likely that one of those tiny internal flaws will turn out to be the weakest link that finally gives way. Okay, so this isn't just some interesting lab curiosity. This discovery has huge, real-world consequences for how we design and build pretty much everything around us. The final word from the research is crystal clear. The whole concept of an infinite fatigue life, that flat line on the SN curve, is, quote, not correct, period. And this matters for things we all depend on. We're talking jet engine discs spinning billions of times, medical implants that absolutely have to last a lifetime inside a person, bridges that vibrate under traffic 24/7. For any component like these, designing with that old myth in mind isn't just wrong, it's a serious risk. So what's the big takeaway here? It's that the only safe way forward for these critical parts is to just abandon the idea of infinite life. Instead, engineers must design for a specific, finite life, say a billion cycles or more, using the real data from these new testing methods to guarantee safety. It really makes you think, doesn't it? The fatigue limit was accepted as a scientific truth for a century, all because we just couldn't see far enough. It kind of leaves you with this bigger question. What other truths that we take for granted are just convenient shortcuts waiting for a new technology to come along and show us what's really going on?